How many paired electrons are there in these atoms? That's you gotta watch the wording here. How many paired electrons? I guess we're counting electrons. Could say how many pairs of electrons are there? All right. Helium, number 2 right there. So the 1s orbital is going to have one pair of electrons. One pair. One paired. 2 electrons paired. Okay. Sodium is number 11. Everything before it is paired because they're full. The orbitals are full, and every orbital has a pair of electrons. Except for the sodium's valent. Here, let's just do it. 1s2, that's a pair of electrons. 2s2, that's another pair. 2p, 6. Now the 2p sublevel has 3 p's, and they're full. So that's 3 more pairs. And then it's a 3s1. That's the valence electron. That can't be paired because it's just solo. All right, so you got 1, 2, right, 3, 4, 5 pairs of electrons. All right, so you got 5 pairs of electrons. Or you can say you have 10 electrons paired. I think that's, I don't know what they're asking for. Then 10 electrons paired. How many paired electrons are there? Ah, man, that is... 10 electrons are paired. That's what I would say. Boron. That's boron number 5. So there's only 2, right? So the first s orbital, that's paired. That's one pair of electrons. And then the 2s, that's another pair of electrons. And then that's the only one in the 2p. So it can't be paired because it's solo. Right, so you got 2 pairs of electrons that are paired. Or you can say 4 electrons are paired. You know, if we give you a question like this, we'll probably ask you how many unpaired electrons are there, because then it's like pretty clear, right? How many unpaired electrons? And then we get to also test you on your understanding of Hund's rule. All right, so if we're going to ask you this, we were much more likely to ask you how many unpaired electrons are there. This is silly. I'll make this up. All right, oxygen. All right. Much rather care about the valence electrons, not these core inert electrons. All right, oxygen, if you were just like, well, that has 8 electrons, let's divide that by 2, and you get 4 pairs of electrons. Well, you'd be wrong, because if you draw the energy diagram, let's go orbital. All right, so oxygen, 8 electrons. All right, in the 1s orbital, that's a pair for sure. All right, ding. In the 2s orbital, that's a pair. Ding. Now, here we go. You got your 2 p's. Now, if you don't follow Hund's rule, and you're like this, ding, ding, no, you're wrong. Because, first of all, you're breaking Hund's rule. All right, so we need 4 more. You go all maximizing unpaired electrons, parallel spin, and then we need one more, and so one of them is going to be paired. So these guys are unpaired. But this one, ding, you got 3 pairs of electrons. 3 pairs of electrons that are paired. Or you could say 6 electrons are paired. All right.